So guys, now that we have completely implemented the thread pool, now I will show you a demo application which actually make use of thread pools. So now in this directory, that is section thread pool, you can find a file whose name is threadpool app.c. So this file actually represents an application which tries to make use of the thread pool, right? So if you open this file, you will find that in this file we have hash included our GL thread library, as well as we have hash included our thread library. Now in this file, to start with, you can see that I have written some very small functions, right? These functions are all thread functions, and for example, the first function, that is even thread work reverse, is used to print an even numbers in the reverse order starting from 10 to 0, right? So this function will print the numbers in the reverse order from 10 to 2. And every time it prints a number, it sleeps for 1 second. Similarly, I have another function which prints the odd number in reverse order, that is from 9 to 1. And again, in this function also we have a sleep of 1 second. So these two thread functions print the numbers in the reverse order, whereas these two functions does the same thing, but the only difference is that they print their respective numbers in the normal order, right? So even thread work would print the numbers from 0 to 8 in the increasing order, whereas odd thread work would print the number from 1 to 9 in the increasing order, right? So you can see that I have written 4 thread functions, and I will discuss shortly that why there is a need of writing these 4 thread functions. Now let's focus on this main function, right? The execution of our application starts from main. So now let us see that how in the main function can I make use of thread pool library. So first of all, when my application starts, the very first thing that I need to do is to actually create a thread pool, right? So the very first thing is that I will create a new thread pool, and then I will initialize this thread pool using thread pool init API. We have already written thread pool init API, right? Then going forward, the next thing that I will do is to place the 2 threads in the thread pool. So I will create thread 1 and I will create thread 2 object. And remember, at this point of time, I am creating the thread object and not actually execution unit, right? And I am placing these 2 objects in the thread pool. So I can use the API thread pool insert new thread, right? So at this point of time, our thread pool contains 2 thread objects, and those 2 thread objects yet not have the execution unit attached to them. It simply means that we have not yet invoked pthread create API on these thread objects, right? Now since this main program represents the application code, so the application has to fetch the thread from the thread pool and assign a task to it to perform, right? So what does this application does is that it will simply invoke an API thread pool dispatch thread, right? And pass the pointer to the thread pool from which the API wants to dispatch the thread, and pass the application specific function which represent a work to be performed by a thread fetched from the thread pool. And the final argument of this API, we already know, is nothing but it served as an argument to this thread function, right? So if you take a look at this application program, the very first thing the application has done is to create a thread pool. Then second thing is to initialize the thread pool. Then application create 2 thread objects and insert them in this thread pool, right? Now an application make use of this thread pool by calling an API thread pool dispatch thread, which will pick up one of the thread from the thread pool, associate this application specific thread function with the thread, and triggers the thread, right? So at line number 84, our application should have triggered 2 threads. One thread to print the even numbers in the normal order, and the another thread is to print the odd numbers from 1 to 9 in the normal order, right? So at line number 84, the application has launched 2 threads already. And let us suppose that our application sleeps for 20 seconds. And when our application wakes up again from the sleep, our application again fetches the thread from the thread pool, assign a different task to those threads now, and again signal those threads. So again we have to make use of the API thread pool dispatch thread. So this small program shows that how a thread fetched from the thread pool can be associated with a new task which the application is looking to perform, right? So if I execute this program, you can see that our application has launched 2 threads successfully from the thread pool, and our application has now slept for 20 seconds. And when our application wakes up, then the 2 threads are again fetched from the thread pool, but they will be assigned different tasks, that is printing odd and even numbers in the reverse order, right? So you can see that thread pools allows the application to reuse the thread again and again to perform different duties without having to create or destroy any existing threads, right?